Okay, so function notation. It's written in terms of a function name. So a lot of times you'll see something like f of x equals, x squared plus 2, or something like that. That might be a function that we have. So the independent variable is x, so that's the input, the independent variable. And then the output is f of x. Now, your book mentions y equals f of x, okay? So if you're doing things in terms of x and y, you want a table of values, you want to graph it on a Cartesian coordinate system, that's what we're looking at. We're saying, well, the input is x and then the output is y, but y is going to be the function x, or the function of x, okay? So it's the f of x. It's pronounced f of x. So f of x. It's not f times x. It means it's a function in terms of x, okay? So that's important to remember. All right. So use function notation to represent a function whose input, okay, so the input is the name of a month. So we're going to need a variable for the name of a month. So maybe we'll use n for the name of a month. And the output is the number of days in that month. Now I want my n to be the number of days. Okay, so I guess I'll make m the month and n the number of days. Okay, so you give me a month, you got 12 of them, say you say April, then I would say 30, right? So if the input's the month April, then I know how many days are in April. The output would be 30, and that would be an ordered pair, okay? But how do we represent the notation? So we can say, if we're letting m represent the month, then we could say f of m is equal to n, in this case, the number of days in that month. Now you have to establish your variables here, and they are either going to tell you what the variables represent, or in this case, we got to choose what variables we wanted to represent. So if you tell me the month, that's the input, then the output is the number of days in that month. So that would be one way. Do you have to call it f of m? No, you could have it be g of m or some other letter. Usually with functions we use f, g, and h. Those are common names for functions, but you don't have to. You could have a cost function. We talk about that. We usually use a c for cost function. Okay, so there's an example, though, of how you would represent the notation. You do have to say what the variables are so that you know which one's which, right? Okay. So example 4, we're kind of going the other way on this one. They give us a function. It says n equals f of y this time. And it says a function n equals f of y gives the number of police officers, n. Okay, so n is the police officers in a town in year y. So it's based on the year that we're counting police officers. Okay, so what does f of 2005 equal 300 represent, or what does that mean? Well, it means then the year is 2005, and in 2005 there were 300 police officers. So we're just trying to establish what's the input, what's the output. And you might have a chart that has, how many police officers were in each year since, 1970 or something. And so you could look up the year, and then it's going to give you how many police officers there were. Okay? So just a little example of that.